Determine all critical numbers for the function f of x equals x to the 5/3 plus 20x to the 2/3. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. The function f of x equals x to the 5/3 plus 20x to the 2/3 is made up of two terms, each of which are a fractional exponent. The denominator of the fractional exponent is the root. Each of them are an odd denominator and therefore an odd root. And an odd root has a domain that is all reals. Therefore, the domain of the function is all real numbers, or negative infinity to positive infinity. The next thing to do is take the derivative. F prime of x equals, the first term is a power rule, bring down the power. Subtract 1 from it, I will call that 3/3. The second term is a power rule, bring down the power, multiply it with the 20. Subtract 1 from it again, I will call that 3/3. The first term is 5/3 x to the 5 minus 3, which is 2/3 power. The second term is 20 times 2/3. 20 times 2 is 40, so it becomes 40/3. X to the 2 minus 3, which is negative 1/3 power. We can now factor. There's a common factor of 5 in the numerator and 3 in the denominator, so 5/3. That'll leave behind an x to the 2/3. And in the second term, 40 divided by 5 is an 8, so I'll leave behind an 8, and the 3 in the denominator was factored out. So just an 8, x to the negative 1/3. We can now factor out an x to a power, and we can factor out the lower power of the two. There is a positive 2/3 and a negative 1/3. The lower power is the negative 1/3, so we can factor out an x to the negative 1/3 power. Factoring is dividing, and dividing is subtracting exponents, so by dividing out an x to the negative 1/3, we can subtract a negative 1/3, which is equivalent to adding a 1/3 to each of the exponents inside of the parentheses. The first exponent's a 2/3. If we add a 1/3, 2/3 plus 1/3 is 3/3, which is 1, and it will become x to the first power. The second exponent is a negative 1/3. We're going to add a 1/3 to that. Negative 1/3 plus 1/3 is 0, and x to the 0 is a 1 times that 8, which will be an 8. We have a negative power. We're going to rewrite by moving that to the denominator. The 5 stays in the numerator. The x plus 8 stays in the numerator. Both of those are to a positive power. The 3 is in the denominator, and the x to the negative 1/3 can move to the denominator by becoming x to the positive 1/3. Now that we have the derivative written as a single fraction and everything is to a positive power, we can set the numerator equal to 0 and the denominator equal to 0. Starting with the numerator, 5 times x plus 8 equals 0. We can divide both sides by 5, so x plus 8 equals 0, and subtract 8 from both sides, so x equals negative 8. And now the denominator, 3x to the 1/3 equals 0. We can divide both sides by 3, so x to the 1/3 equals 0. And now we raise both sides by the reciprocal of the power of x. It's 1/3 power, so the reciprocal of that's 3 over 1, so we raise both sides to 3. The reason for that is when we raise and raise again, we multiply the exponents. 1/3 times 3 is 3/3, which is 1, and it becomes x to the 1 power, so we can solve for x. On the right side, 0 cubed will be a 0. Now we check to see whether these are in the domain. The domain here is all reals. X equals -8 is a real number, so we keep it. It is a critical number. X equals 0 is a real number, so we keep it. It's also a critical number. And there are the two critical numbers for the function, x equals -8 and x equals 0.